Welcome, dear young chemists, for the lecture on Hammond postulate. Postulate states that the structure of the transition state in any reaction is closer to the species to which it is closer in energy. Therefore, when we draw the energy profile of a reaction, we have to put the the transition state closer to the species which is higher in energy. According to Hammond's postulate, the transition state of a reaction should resemble the structure of the species to which it is closer in energy. Let us consider the energy profile of an exothermic reaction. In an exothermic reaction, the reactant has higher energy than the product. Therefore, the transition state of this reaction should resemble in structure more with the reactant than the product. Therefore, the hump in the reaction, which is representing the transition state, should be put closer to the reactant of the reaction. In case of endothermic reaction, the product has higher energy than the reactant. Therefore, the transition state, the hump in the energy profile, should be placed closer to the product. In all exergonic reactions or exothermic reactions, the reactants are having higher energy than the products. Therefore, the transition state of the reaction should be drawn closer to the reactant side. See, here I have shown two energy profiles for exothermic reactions. So here in the first picture, this is representing the energy profile of exothermic reaction, where reactant has higher energy than the product, and the transition state is supposed to lie closer to the higher energy species, but it is shown closer to the lower energy species, that is the product. Therefore, this energy profile is not correct for an exothermic reaction. Whereas the second diagram shows the transition state being closer to the reactant, which is a higher energy species. So this is the correct energy profile for an exothermic reaction. Similarly, for all endothermic reactions or endergonic reactions, the product has higher energy than the reactant. And here, the transition state, which is supposed to lie closer to the species higher in energy, here in this diagram, it is shown closer to the species that is lower in energy. Therefore, this diagram is incorrect. So the correct energy profile for the endothermic reaction or endergonic reaction is this one. Here, in any endothermic reaction, the product has higher energy than the reactant. Therefore, the transition state is lying closer or shown closer to the side of the product. Let us look at a concrete example for Hammond's postulate. Here we have taken the conversion of an alkene into a carbocation using an acid. According to Hammond's postulate, the transition state should resemble the product in an endothermic process. The reaction we have taken is an endothermic process. Alkene is the reactant, carbocation is the product. Therefore, the transition state should more closely resemble the product, that is the carbocation intermediate. So, the structure of the transition state in this reaction more closely resembles the carbocation, which is the product of the reaction, than alkene the reactant. A reaction of an alkene with an acid to form a carbocation. This is an endothermic process where the reactant is an alkene, the product is carbocation. And in this endothermic reaction, the product carbocation has higher energy. Therefore, the transition state of the reaction should resemble more with the product than with the reactant alkene. So any factor that influences the stability of the carbocation, the product, will affect the stability of the transition state also. Thank you. Learn chemistry with interest, and chemistry will take you to bigger heights. Thank you.